because that's what's inside our square root, right? So what does that do for us? Well, we've got integral of, well, 3 times the square root of 11 tangent theta, right, plus 1, divided by the square root of, apparently, 11 secant squared theta, right? Now what's my du? Square root of 11, right? Secant squared theta d theta, because the derivative of tangent is secant squared. If you didn't know that before this, you probably know it now, right? So I need to write that du is actually square root of 11, right? Secant squared theta d theta. Do you see what's going to happen with those squared 11s cancel, right? Yep.
Where did the plus 1 come from? The tangent squared theta plus 1?
That's the 11. It's like when I factor 11 out, it leaves me this 1. The ultimate judge of any step like that is when you multiply it back out to get back where you started, right? So factoring's just unmultiplying, so when in doubt, multiply. Okay, so, well, those root 11s cancel. And this is secant squared, so we're left with a, anyway, let me just go for it here. So we're going to have integral of 3 root 11, root 11, tangent theta, secant theta, d theta. Oh, my bad. What have I not done? Yeah, it's 3 tangent theta plus 1. Watch out for that. Parentheses are our friends. Those secants do cancel, so we're left with secant theta, d theta. So what we're up against here is 3 square root of 11 integral of tangent secant plus, and now that 3 root 11 only multiplies the first term, not the second one, right? So the next one's just a plain old integral of secant theta d theta. And those are integrals we can do, right? So what does it look like? We got ourselves a, let's see here. I'm gonna put it over here. Equals 3 root 11 secant theta plus the natural log of the absolute value of secant theta plus tangent theta plus a constant. Now we'd like to make it pretty, right? How can we make this one pretty? Let's see here. I had a tangent theta. Tangent theta is what? U over root 11? So that's supposed to be opposite over adjacent, yeah? So we got like a u on our opposite side, square root 11 over here, and then square root of u squared plus 11 for our hypotenuse. Here's my theta. So let's see here. Secant theta is what? So it should be hypotenuse over adjacent, right? Which in this case is the square root of u squared plus 11 divided by root 11. So that's nice. That's going to cancel. That square root of 11 will cancel with the square root of 11 that's in the answer there. That's nice. So I've learned this much already. The first term is 3 times the square root of u squared plus 11. That's not bad. And then let me work on what's secant plus tangent look like here. Well, secant plus tangent is square root of u squared plus 11 divided by root 11, right? Plus, what was tangent theta? Well, u over root 11, right? So we've got plus the natural log of absolute value u plus the square root of u squared plus 11 minus the natural log of the square root of 11 plus c. So what I did there was this thing I did before, right? Anytime you've got like natural log of a over b, you can rewrite it as like log a minus log b, right? So I'm pointing out that, you know, we can rewrite this as u plus the square root of u squared plus 11 divided by root 11. So I'm thinking of taking that multiplication by 1 over root 11 and just subtracting the natural log of the square root of 11. And so, you know, it's just a constant, so we can just pull it into the integration constant. But what does this give us? 3 square root. Now what is u squared plus 11? Right, tracking back, it's what? It's exactly x plus 2 squared plus 11, right? Which, going back to our original form, is precisely x squared plus 4x plus 15. So just undo what we did. X squared plus u squared plus 11 is actually x squared plus 4x plus 15. And then you've got plus the natural log of the absolute value of, well, u was x plus 2, and then plus the square root of x squared plus 4x plus 15. Now, of course, you could leave it in terms of x plus 2 squared. That would also be fine. But I'll add a c bar here just to respect the fact that I lumped the other number into the original c. And there you go. That's how this goes. What do you guys think? Any questions? All right, well, I think that's a pretty good place for us to stop today. I could squeeze another example in, but you guys probably got stuff to do, so we'll stop here.